Go ahead and open your books to page 233. We are in lesson 15.3 called Writing Equations from Verbal Descriptions. And we are going to do exactly that. Write a linear equation given a verbal description. And remember, we're usually doing that in slope-intercept form. And then we're going to graph and analyze functions on the same coordinate plane. Question 1. Suppose that the speed limit on all parts of Interstate 20 has been changed to 70 miles an hour. So now Travis finds that he can average between 50 miles an hour and 70 miles an hour on the trip between Pecos and Dallas. So before he was only going 60 miles an hour, and then 45 was his minimum. So we are going to write an equation that expresses Travis's distance d from Dallas as a function of the hours h since he left Pecos if his average speed is 50 miles per hour. So we're going to start with d equals my slope times h plus my y-intercept. Now, what is my speed here? Our average speed is 50 miles an hour. But remember, we're getting closer and closer to Dallas. Our distance from Dallas is decreasing, so we actually need to write this as a negative 50 for the slope. Plus, do you remember how far apart they were? How many miles away Pecos is from Dallas? Hasn't changed. It's still 450 miles. Letter B. Again, we're going to write an equation. Same thing again, but this time we're going to focus on an average speed of 70 miles an hour. So my distance equals, my average speed is 70 miles per hour, but we're decreasing by 70 miles an hour because we're getting closer and closer to Dallas. Plus, how far is Pecos from Dallas? What's our starting distance? Our y-intercept here is that 450. Question C. We're going to graph both of these equations from letter A and B. But if you remember from before, we're going up by 45s here. So it's going to be very difficult to figure out how to go down 50 over 1 and down 70 over 1. We're not going to be very accurate. So what we could do, though, is we could find our x-intercepts. We could find the total number of hours it takes Travis to drive from Pecos to Dallas. So when he's at Dallas, he's obviously arrived at Dallas. So my distance from Dallas would equal 0. So we're going to plug in d equals 0 for both of our equations, and we're going to solve for h hours. Okay, so 0 equals negative 50h plus 450. We need to figure out the number of hours. So let's subtract 450 from both sides. This cancels out. Why? Because we're trying to get this alone, trying to isolate it. So we get negative 450 equals negative 50h. So we need h completely alone. Currently it's being multiplied by negative 50. So the opposite is to divide. Two negatives make a positive. How many times does 5 go into 45? These cancel, these cancel. So we get h equals 9 hours. So this is my x-intercept. This is my 0 of the function. So we know that our y-intercept is at 450. Our x-intercept is at 9. So what I want you to do is use a straight edge and connect those. So now we're going to do the same thing for our other equation. Go ahead and pause and solve for h. We get a decimal this time. 6.428. So 6.43. So pretty much like 6.5 is our x-intercept. Our 0 of the function, that's how many hours. So do your best. And again, use a straight edge and connect those two things. This is our 0 of the function, total number of hours. So connect your x-intercept to your y-intercept. Letter D says to shade the region of the graph above for the ordered pairs h, comma, d, so that means hours, comma, miles, hours, distance, such that h represents all the possible times, d represents all the possible distances from Dallas. So remember yesterday, where did we shade? We're going to shade in the middle of these two lines. So fill that in with your pencil. This is our common shaded region or our solution region. And question E says, describe Travis's possible distance from Dallas after 4 hours of travel. So remember how we figured this out by drawing a vertical line at h equals 4? So if I go back to my graph, I'm going to draw a vertical line at h equals 4, and I want you to guess where you think those intersection points are. There's one down here, and there's one up here, and they're not at perfect numbers. Okay, so it's okay if you're just doing a rough estimation, guessing whatever you think this point is and this point is. So kind of draw a line over with your pencil, make a guess. So Travis will be at least, throw out some numbers, 160, 165, 170, 180, but not more than, what do you think? 240, 245, 250, 260, 265. It all depends on how straight our lines are, where we put that 6.43 at. So it's okay if our numbers aren't exactly the same. It's just an estimate. And then let's take these numbers and we're going to write them as an inequality. So if you chose different numbers than I did, you're going to use whatever numbers that you have in your book for question E. So if you used 160, you would write 160 first, etc. So 170 is less than or equal to distance less than or equal to 250. So my distance could be in between these two numbers. And we are done talking about Travis driving from Pecos to Dallas. So in the check your understanding box, we have a new scenario, new story problem. Sumi and Jerome start riding their bikes at the same time, traveling in the same direction on the same bike path. Sumi rides at a constant speed of 10 feet per second. Jerome rides at a constant speed of 15 feet per second. Write an equation that expresses the distance d that Sumi has traveled as a function of the time s in seconds since starting her ride. Okay, so we need to start with d equals. What is Sumi's speed? It is 10 feet per second, and it says to use an s for seconds. Now, it doesn't tell us they're going from point A to point B. Okay, it doesn't say they're starting at the park and they're going to the ice cream store. We don't know. So we're going to make this a positive 10 for our slope because we don't know if their distance is decreasing. Maybe they're just counting the total number of miles. We're starting at the same point and we're going to ride 5 miles together. We don't know. And we don't know anything about their starting point, again, so we don't have a y-intercept here. So that's the only thing that we can write for Sumi's equation. So go ahead and fill in Jerome's equation for question 3. This equation is d equals 15 feet per second. Question 4 says graph the equations from items 2 and 3 on the same coordinate plane. So what I need you to do in the My Notes section of your book, you are going to draw an x-axis and a y-axis. So use up as much as you can of the My Notes section of your book. There's a graph paper portion on purpose. Okay, and I want you to go from like 0 to 8 or 9. So your x's, you're going to increase by 1s. Your y column, go up by 5. So 5, 10, 15, 20, 25, 30. Go ahead and pause the video. Take the time to do it. We have to do it again on our homework. So I'm going to start by graphing Sumi's first, which was a slope of 10 and a y-intercept of 0. So if I write a plus 0, that kind of shows me that my starting point is 0. So my origin here is 0, 0. And if I go up one box, that's only 5 numbers, but I have a slope of 10, so I need to go up 2 over 1. So up 5, 10 over 1. Up 5, 10 over 1. And then you can use a straight edge again to connect these. And I have an arrow at the end of my graph because it keeps going. Jerome has a speed or a slope of 15 and a y-intercept of 0. So we're going to have our same y-intercept at 0. And then I need to go up 15. So 1 box is 5, 2 boxes is 10, 3 boxes would be 15, and then over 1. 5, 10, 15 over 1. Keep going. And then again, you can use a straight edge to connect these. Jerome's line is a little bit steeper. He's riding a little bit faster. So question 5 says, explain how to use your graph to find the distance between Sumi and Jerome after they've ridden their bikes for 5 seconds. So this would be on our x-axis, or our seconds axis. Remember how we were drawing in those vertical lines? So we're going to go over to 5 on the x-axis. And we could draw in, physically, if we wanted to, our vertical line. I'm only going to draw it from like here to here, basically. Or you could just look, whatever you prefer. And hopefully you can kind of see here the distance between them. Right? If I am looking, I'm noticing that I have an intersection point at 50, and I have another intersection point at 75. So Jerome is at 75, Sumi is only at 50, so the difference between those is 25. But again, we're looking for our intersections points, the low number and the high number, after 5 seconds.